Welcome to the fourth experiment of the data structures lab, which is basically implementation of stacks and queues using linked list. So we have created a structure called node, as we did with int data and next pointer and a top pointer of type node, which is basically a structure again. We've created a class stack, which is all the functions of a stack. So let's explore them. We have a normal is empty to check whether the stack is empty or no. In pop function, we check if it's empty and we print the error message. If it's not empty, we create a node called temp, which is basically initialized to top. And int value will basically store top's data. And finally, we move top to the next field and we return the value and delete temp. In push, we pass the data to be pushed on to the stack as a parameter. We create a node temp, a new node called temp. Its data field will be initialized with the value of x, and temps next will be pointing to top now, and top will be made equal to temp. And finally, our display, which we create a node t equal to top, and we check if it's empty. If it is empty, there's nothing to print. Otherwise, we run a while loop where t is not equal to null, which will go right till the last of the linked list and will print the data and keep incrementing temp to its next field. We provide the user with a menu-driven program, and let's see how this program executes. So we perform first insertion function, we enter the element 12. Perform insertion again, we enter element 13 and 14. Finally, we display the stack. As you can see, we have 12, 13, and 14. And for deletion, we enter, we can see the top of the element was popped 14. So this is the first program of this of the fourth experiment. Moving on to the second program, which is implementation of queue using linked list, where similarly we create a structure called node. We have a class queue with the functions necessary, but here we have a front and rear pointer instead of a top. So empty, and moving on to the main function, which is basically insertion. We provide the data to be inserted, create a temporary node, which is the new node. Its data field contains the value x. Temps next will be equal to null, and if it's empty, we check whether the queue is empty. If it is, we equate front equal to rear equal to temp, which is basically the first element of the queue. Else, we do a normal insertion in the queue where we insert at rear position. In deletion, we check whether queue is empty. If it is, then there's nothing to be deleted. Otherwise, we create a node temp which is equal to front. Now the value of this front will be stored in int val, and finally front will be moved on to its next field. Now we can return value and we can delete temp. Display is pretty much the same, where we run it till the end of the linked list. And finally, we provide the user with a menu-driven program. Let's see how this executes. So we perform insertion. Now when we display it, we get 12, 16, and 44. Now if we delete, deletions are supposed to be happen at the front end. So when we delete, element 12 is deleted from the front, and at every point insertion was done at a rear. So this is the final experiment of the exercise 4, and the output has been verified. Thank you.